Hi, it's Joe here at Measurement Solutions, and today I'm going to run through a very quick scan of this part using our Peel scanner. So we've got the Peel software open up in front of us here. I'm just going to hit New Scan and we're going to open up a new scan for this part. The first thing it's going to do is ask us for a few parameters. Now I describe this as kind of bowling with the rails up. So we've got some really easy ways to decide which size and detail we're going to scan with. We've got some quick pictures to help us decide on the object size. We've got some details here to decide whether we want a verified, a fine, a normal or a coarse output from the mesh. Once the mesh is processed, we can decide whether we want something balanced, which is going to give us the best possible result in the quickest amount of time. If we've got more time, we might want it to run an enhanced or a watertight version. If we want just the raw results, we can hit Express, and this is going to give us the results in the quickest amount of time possible. So for colour, we can either choose no colour, low res, high res, or select some custom colours. In this case, we're going to scan with no colour. I'm going to hit next. The calibration is already done for this scanner for today. So I'm going to grab my part and just hit play on the back of the scanner. You can see we're starting to pick up data. Anywhere that's green, we're picking up a good amount of data from. Anywhere that's red means we're too close, and we're going to get some haptic feedback from the scanner to tell us that we're too close. And if we turn blue, it means we're too far away. And again, that haptic feedback is going to kick in on the scanner. So I'm just going to work my way around the part. We described it as digital spray painting. We want nice smooth movements around the part, picking up as many areas as we possibly can. Like I say, we want everything to be green. Means we're picking up a good level of data. Now we can't overscan a part. We can definitely underscan a part and not get enough data. For the purpose of this particular video, I'm not going to go too detailed into the amount of data we've got. The great thing with the targets on the part is we pick it up mid-scan, turn the part around, scan the back side of the part that we couldn't reach particularly easily. Again, we're just going to work our way around the part to get as much data as we can. So that's the first side of the scan done, or at least as much as we're going to do for now. Next thing I'm going to do is hit next, and it's going to automatically detect a clipping plane for us. If we want to move this, we can grab the arrow to move the clipping plane up or down. In this case, the clipping plane where it was fine. I'm going to hit continue, and it's going to delete the table. Next, I'm going to select the main body of the scan and just remove any kind of isolated patches or noises around the scan to give us this part. So this gives us a scan of the top surface of the part. If I hit add new scan, we're going to be able to do another scan of the underneath and merge those two scans together. Again, we've got targets on the inside of the part. The Peel scanner will track on targets. It'll also track on texture and geometry as well. So multiple ways to be able to pick up the scan data. So in this case, I'm going to use the benefits of having targets on the part to pick up the part and just scan it with my hand. So again, I'm going to hold the part, hold the scanner, just hit play. And again, any green areas, we're picking up a good amount of data. If we're red, we're too close. And if we're blue, we're too far away. So I'm just going to work around the part to get as much data as I can of the inside in as quick a time as we can. Put it down and just scan around this side as well. This is just going to capture a couple of common surfaces, which is going to help us remerge the scan back together in just a moment. So we've got a fairly decent coverage now of most of the inside of the part. If we want to zoom in on any particular area to make sure that we've got data there, we can use the zoom function on the back of the scanner to zoom in and see exactly where we're picking up data, where we might have some holes that we need to fill in with some more in-depth scanning. Okay, that's going to give us enough data for now. Again, we're going to hit next. It's going to automatically detect where that table is for us. In this case, we had it in our hand for a little bit, as well as the table. So let's select a surface, we'll select the table, hit continue, it's going to delete the table. Still got some areas here where it just picked up a bit of my arm as we were scanning. Again, we'll select the main body, remove any isolated patches to leave us with just the inside scan of this part. Now when I hit next, the software is going to automatically merge these two scans together. We scan this little section on both scans, and it's used those few targets to merge the part together. Let's hit next to accept that, and now we're going to align the part. So when we scanned it, the scanner and the software doesn't know exactly where it is in space, so we're going to be able to align the scan. The software is going to automatically put the 0 point at the centre of gravity of the part, so that's going to help us with the initial alignment, and then we're going to be able to fine-tune that alignment ourselves. So maybe we want the Z-axis to be on this cylinder. We're able to do that when we get into the alignment section. So now we're into the alignment. We're going to use this cylinder as our Z-axis. So if I just hit, it's pretty much already in the Z-axis. Let's hit the X-axis, select this cylinder, and it's going to flip the part over to make this cylinder the Z-axis. If I want to lock a plane, so let's make the YZ plane on this plane here. And the next thing we're going to do is go through to some improved steps. So we've got a few kind of basic tools here to help us fix up this mesh. We can fill holes. This is going to allow us to select a boundary of a hole. It's going to automatically fill for us. We can decimate the triangle count. So if we want something a bit more lower resolution, we can do that. The Creoform software will automatically apply what's called a smart resolution. So in these flat areas, we're going to have a decimated triangle count anyway. In these more detailed areas, we're going to have a finer mesh resolution to pick up those details for us. We can do some smoothing operations. So if we've got particular areas or logos that we want to get rid of, we can remove those in the software here. We can also sculpt, so engrave or emboss logos or notes or initials on the part to help identify it. And we can edit the boundaries as well. So if there are any sharp boundaries that we don't like, we can edit those to make them nice, smooth cylinders or ovals, whatever we want to do there. And we can remove spikes as well. So any spiky data, just remove those spikes. Okay, so the next part of the process, we're going to send this mesh into VX Elements. So this is where the really powerful reverse engineering or inspection processes take place. So we're going to, in this case, we're going to use VX Model. So we're going to go through a reverse engineering workflow. Here's the mesh, the final mesh. You can see the resolution. When we looked at the previous version, we were seeing a sort of a preview of the resolution. This is now the final resolution. You can see we've got some gaps just where we didn't really take enough time to scan some particular areas, but we did a very quick scan. But here we can do some really advanced fixing on the mesh, and also create some entities that we can take into our CAD software to use for reverse engineering. So we've got the hole fills, these improved steps that we saw in the previous version, but that's not what we're particularly interested in here. Here we're going to do some reverse engineering. So we can take this mesh and put it straight into a few packages. We can go straight into SolidWorks, Inventor, Fusion 360 and Solid Edge. In this case, Fusion 360 is the only software that I've got uploaded on this machine. So I'm just going to hit transfer. It's going to open Fusion 360 and put this mesh into Fusion 360 for us, ready to start our reverse engineering. So we could either start to sketch around the mesh elements using the mesh as a reference and a guide for us to start creating this part as a CAD model. But that's going to be very time consuming. And what we might want to do is bring in some step elements. So for example, if we were trying to redraw this section here, I might want these two planes and some sketches. so we can create those in VX Elements. So let's hit a plane. We're going to create a plane on this surface here and another plane on this surface. Let's hit OK. We're also going to create a cylinder around this circle here. And then we're going to use some more tools within VX Model to create some circles which we're going to export into Fusion. So I'm going to create a circle using a plane cylinder intersection. The first circle I'm going to create is on plane 1 where it intersects with this cylinder. So OK. Second one is on plane 2 where it intersects with the cylinder. Okay, so now if we dig into our entities, you see we've got these two circles. If I right click, transfer to Fusion 360, we're going to take these sketch elements straight into Fusion 360, and I'm going to be able to use those sketches to start to reverse engineer the part. So if we open up Fusion 360 now, you can see under sketches, circle 1 and circle 2 that we've just created. There's lots and lots of different entities that we can create in VX Model to bring across. We can do cross sections, silhouettes, obviously the planes and circles that we just saw. Pipe centerline, really difficult one to be able to create manually. You can automatically create that in VX Model. Okay, so that's pretty much all I was going to show you today. Hopefully you found that useful. If you've got any questions, then please feel free to drop me a line. Cheers.